Tabby, I don't know if you remember, but about a week ago, I stood up here and I started reciting the alphabet. And you all kind of, what? But you all figured out A, B, C, D. And I said, the periodic table is the alphabet of the universe. That was my analogy. Well, today we're going to learn how to spell. 2-letter words for the most part, but we're going to learn the rules for combining elements and naming. The rules for combining elements and naming start out pretty easy, but then they get pretty complicated because there's exceptions and weirdness. And it's the universe that we live in. Sorry. So this first bit hopefully is a bit of review. An atom is the smallest part of an element. Atoms combine to form another word that starts with the letter C. What do we call it when atoms combine? Compound. Good. I didn't make that one a candy one. So when we have compounds, we call the smallest part of a compound a molecule. So a molecule is the smallest part of a compound. You've probably, just by growing up, heard and memorized some compounds. CO2, carbon dioxide. Most of you probably have heard that one. H2O, water, a water molecule. Put your pencils down, look up. Hopefully this is review. All compounds have a name, carbon dioxide, and a formula, CO2. Sodium chloride, NaCl. This name is generally composed of the names of the elements in the compound unfortunately with some exceptions. So Ariel, I'm going to be giving you some rules, but they're mostly rules, not, and almost any rule I give you in today's lesson, we'll find an exception for. Sorry. The formula uses the symbols from the periodic table. Na, Au, W. And the key thing with the formula, it tells how many atoms of each type are in one molecule. So if I say CO2, one C, one carbon. Here, let's write it. You don't need to write this down. But the formula for carbon dioxide, you need one carbon, you need 2 oxygens. So for every carbon, you need twice as much oxygen if you're planning on creating CO2. Is that a hand up, Ralph? Yeah. Stretch. Okay. What's the chemical formula for water? You all kind of have memorized this one.
H2O.
Careful. You got it a little backwards. H2O. So, for every oxygen, how many atoms of hydrogen do you need? 2. You might recall near the end of that video, it showed you a chromosome that was 37 billion atoms long. This is why I said we're learning 2-letter words today. They can get big. Come back here. We're going to skip this activity, and instead we're going to go right here to the naming rules. So, in theory, you learned something called the Iodide rule last year, but I'll teach it as though you've forgotten it. When we're naming ionic compounds, we always write the name of the metal first. So right now, just to reinforce things, glance at your pink periodic table and look at the left side. Most of that are the metals. Thank you, Ava, for getting out your pink periodic table. Yes, I noticed these things. And then you change the ending of the non-metal to Ide. So just some examples. I don't remember, did I include these in your notes, or is this just for us to look at? It's not in your notes, so let's just look up then. Iodine and copper, which one would you write first? Which one is the metal? Copper. You would call this copper iodide. If zinc and oxygen were combining, which one would you write first? You would call it zinc oxide. Fluorine and magnesium, you would write magnesium first, and you would call it magnesium fluoride. So what will the endings of the following become? What would you change fluorine to? Fluoride? Oxide, not oxide. I know that's a bit of a weird one. Nitride, not nitride. So there's a few weird kind of exceptions. Okay? Yeah, I don't think that was in the notes, right? Did I give you a copy of the notes, though? I did. Yep. My mouse has suddenly stopped working. So I think now you have a chart, yes, with AgCl and ZNO and CaCl2. We're going to fill these in together. Oren, quick like a bunny. Actually, Oren, can you wait till we fill in this chart and then go, okay? So if you saw AgCl, what will we call that? Step one, you got to find Ag. What element number is Ag so that everybody else can spot it? What element number is it? So find 47. Find element 47 on your periodic table. Ag is silver. So we would call this silver what? Chloride. Write that in your chart, please. Oren, if you do the next one, I'll let you sneak out to the bathroom because that, no, you kind of got the hang of this. The next one, ZNO. I think it's the next one in your chart, isn't it? Mr. Duick, why don't you get a copy of the notes and have it in front of you? That would be clever. Sorry? I think so. Mister, that was funny. You think? They only get worse. I have told you they get worse, right? I have never told you that the jokes are funny. I hope not. Yeah. Okay. Anybody think they know what CaCl2 would be called? Tabby. Calcium chloride. The 2 is we have to use when we're coming up with the formula, but it doesn't show up in the name. Calcium chloride. What would MgF2 be? I always got to be careful because I get magnesium and manganese mixed up because they both have M's and G's in them. Casey. Yep. Little note, by the way, when I teach, I will occasionally call on you even if your hand is up. When will I do that? If I sense you're zoning out and you need that gentle shock of, oh, I got to get back my brain here, but I will try and call on you when I'm pretty darn sure that you know the answer. But at the same time, mistakes are expected, respected, inspected, corrected. I don't mind making mistakes. It's how we learn. Sarah Lee, can you, Sarah Ashley, yes? No, Sarah, yeah? I got it right. I'm learning names still. Can you next one? I agree. By the way, in North America, we say aluminum. In Britain, they say aluminium. And actually, there is an I. They named it. We're the ones that have it wrong. But okay. Yeah. Aluminium. I thought it was the other way around. No, they named it. Aluminum sulfide. Ariel. Can you tell me the answer to the next one? What's the metal? Can you find Ba on your periodic table, kiddo? Yeah, I know, this is really sneaky mean of me. Oh, do it, really? Earning my way? Yes. I'll come back to you with another one. Barium. What element is barium? What do you do when somebody dies?
Please
Barium.
interruption at this time,
Right.
Mr. Gerard and Miss Gilmore. Can you kindly escort your classes to photos? Gilmore
Not quite
and
yet.
Gerard.
What's the I? So we're going to call this barium iodide. Quick like a bunny, mask up. Okay?
What about the people that wanted to answer?
I got to get everybody comfortable with making mistakes. So, well, it's going to get, sadly, it's going to get tougher pretty quick. Shh, quiet, please. Gotta wait. We've learned that atoms gain or lose, folks. We've learned that atoms gain or lose electrons in set ways to get a full outer shell. This is the ion charge in the right side of your periodic table, the the 2 plus, or the 3 minus, or just the plus sign or the minus sign. Do number 2 and 3 on the worksheet, remembering to change the endings of the nonmetals to "ide." So now I think you have, I was going to stand up and get a copy of your notes so that I can follow along with you. So number 2 and number 3, you have this little chart here. Let's see if we can fill this in. What's the ion charge? First of all, what's the symbol for barium? Ba? What's its ion charge? Calcium? So I'm going to pause. I'll walk around if you need help. I'm going to freeze the screen. See if you can fill in the element name, the ion charge, and then see if you can come up with the "ide" ending for each one of these as well. Take about 2 minutes to do that. Now we get to a little trickier. So, okay. Some patterns. You hopefully notice the ion charge that forms on the first column, alkali metals, is all, guys, let me try that again. The ion charge that forms on all the alkali metals in the first column is what? Yep. Good. What's the ion charge that forms on all the alkaline earth metals? Second column. 2 plus. What's the
interruption? Can we have Mr. Bain's class or Mr. Berard's class?
Okay.
To the mini
What's the ion charge on the elements in column 16? What's the ion charge on the halogens? And what's the ion charge on the column 18, noble gases? Which is why they don't form compounds very readily. So, rule number 1, if it's an ionic bond, you write the metal first. Rule number 2, you change the nonmetals ending to "ide." Now it gets trickier because now we're going to try and come up with the formula where those subscripts come from. So far, again, we can name a compound if you give me the formula, and we can determine the ion charge from the periodic table. How could we get the formula from the name? That's the trickier part. So, when ions combine to form compounds, they will combine so that the ion charges are balanced or equal to, when you balance the positives and the negatives, what should they add to if we have a compound? What would neutral be as a number between -1 and +1? Yes. Okay. Shh, quiet, please. The ion charge, folks, I need the little interruptions to stop. I know it's a lot of talking. The ion charge is the charge that forms on an atom when it gains or loses electrons. Where can we find the ion charge? I was going to write it out, but I think it's easier if you just draw kind of a square, like on your periodic table, right there, right, top right.
On our periodic table?
Look at the squares of each element. Is the ion charge not on the top right? Yeah. So you can write top right corner of periodic table square, or you can just do that. Okay. When an atom loses electrons, because electrons are negative, the ion will have a positive charge. When an atom gains electrons, because electrons are negative, the ion will have a negative charge. This is the tricky part because it would have been nicer if we'd made electrons positive, but we didn't. So the chemical formula tells us which atoms are present, and it tells us how many of each atom there are. Ions combine in set ways to form compounds. You may have learned something last year called the Crisscross Rule or the crisscross trick. So let's suppose that I want to combine sodium iodide. And I don't think I have this in your notes, so just look up. Eventually. Here's sodium. What's the ion charge of sodium, upper right? Plus. Here's iodine. What's the ion charge? Phone away, Oren. What's the ion charge of iodide? Okay. The crisscross rule says this. To write the chemical formula, no, just watch. That will move there. That will move there. So the chemical formula is going to be Na1I1. Although, do we write ones?
No.
Okay. Look up. What if I wanted to write calcium iodide? And this is the work I typically just do in the margin. I would write down Ca. Riley, what's the ion charge on Ca, on calcium? 2 plus. I would write down I and negative. And then the crisscross rule says that's going to move there. That's going to move there. The formula is going to be Ca1, I2. Although, will I write the 1?
No.
So I'm going to stop writing the 1s from now on. Okay? That is the formula for calcium iodide. That's the crisscross rule. So let's write that in our notes now. Since the overall charge in an ionic molecule is 0, the positives must balance the negatives. So, as an example, suppose a metal ion is in column number 2, where they all have a charge of 2 plus, Ava. If an ion has a charge of 2 plus, it can form a compound with either 1, 2 negative, or 2, 1 negatives. Or we can get more complicated as well, but for now, that would be the easiest way to form compounds. But if you're looking for a systematic way, Ava, that crisscross rule will work most of the time. Could you leave the door ajar, kiddo? Thank you. How's the back? So, 1 ion charge of -2 because +2 plus -2 equals 0, or +2 plus 2 times -1. also equals 0. And then I think I included a bunch of things about hooks, and I changed my mind. So we're going to go like this.
Where did it go? I don't have time to write math that fast.
Don't worry about it. We're going to kind of, what we're going to do is we're going to just write the formulas. It's actually, no, I'm going to skip this. I'm kind of deciding on the fly here. Going to skip this.
We're skipping the boxes.
And you want to find, if you turn the page,
We're skipping math classes or
so that we're just beneath this little chart here that says AL203, a tough one. We're right here.
So we're skipping it.
Yep.
Cross it out.
We're going to just bring in the crisscross rule. So another way to think of this, easier, but also easy to make a mistake, is called the crisscross rule. And the crisscross rule says this. Write the ions with their charges or in phone away, kiddo. Okay, and can you leave it face down? Otherwise, I'll take it away from you in a nice, loving teacher kind of a way. So let's combine aluminum and oxygen. What would the name of that be? Aluminum what? Okay, aluminum oxide. What would its formula be? If they asked me to write the formula for aluminum oxide, I write the ion charge, 3 plus. What's the ion charge? Casey's figuring this out on oxygen. Cassandra? And then that's going to go there. That's going to go there. Al2O3. And the math of that is Al2 is positive 6, O3 is negative 6. And positive 6 plus negative 6, 0. That's the crisscross rule. So you move the number, but not the plus or minus, just the number, from one ion to the subscript of the other ion, and repeat. Oh, and you don't need to write a 1. We understand it's there. Okay? Where do kids get this mixed up? They confuse these numbers with those numbers. They confuse the subscripts with the ion charge. Don't do that. I don't have a really good way to remember it. Whoop, too far, Mr. Duick. So I wrote here, the location of numbers is very, very, very important. The subscript, which is the lower number, is the number of atoms. The superscript up there, upper number, is the ion charge. If you get them mixed up, if you put them in the wrong place, this is the risk with the crisscross rule. I won't give you part marks. You got the wrong chemical formula. Sorry. So, I think you have in your notes, try these ones. What's the chemical formula for calcium chloride? You would write the ion charges, and then, Nick, we're going to crisscross. I really encourage you to draw the arrows in. For me, that helps me not make a silly mistake. Jada, what's going to be underneath the calcium as a number? 1, technically. Am I going to write it? No. What's going to be underneath the chlorine? And chloride is what I would call it. There's the chemical formula for calcium chloride. Is that okay, Nick? We already did aluminum oxide. What about NaF? Casey?
Oh, it's just an NAF.
That's why the alkalines bond so nicely with the halogens. What about now here's the final part of the crisscross rule. What about Ca2O2? We don't write that. The final part of the crisscross rule is you reduce it to lowest terms. Is there a number that goes into both evenly? So you would divide by 2, and the reason is, Cassandra, look, this has a charge of +2, this has a charge of -2. I only need 1 and 1 to bond them. I don't need more than one of them because they exactly cancel each other out. So the crisscross rule is, it's actually crisscross and then reduce if you can. Reduce to lowest terms, okay? So let me give you another example then. If I have, let's see, I gotta pick one that works that isn't crazy. Sure, if we wanted to combine W with Se. Find W on your periodic table. Your hint is it's in the 70s. Tungsten. What's its ion charge? Find selenium on your periodic table. It's in the 30s.
34. Oh, it's selenium.
Yep. And we would call this then tungsten selenide. But when I crisscross, I wouldn't write 2 and 6. Is there a number that goes evenly into 2 and 6? I would write W1 Se3. I would reduce it like a fraction to lowest terms. Divide by whatever goes evenly into both numbers. In this case, 2. Yep. Yep. Okay? So you have to reduce the subscripts to lowest terms. So in your notes, I'd like you to try 5 and 6. So we're going to do the first one together. Let's do sodium and nitrogen together. You have also lithium fluorine and you have lithium oxygen, but the third one down is sodium nitrogen. What's the chemical formula for sodium?
Na.
And it's Na plus. Nitrogen is N3 minus. What's the formula going to be? Na3N. Crisscross. What would you call this?
Sodium nitride.
Sodium nitride. How many atoms does this molecule have grand total?
4.
4. You need 4 of these atoms to form one molecule of sodium nitride. So I'm going to pause now. I'd like you to finish question number 6. And I'd like you to, I think we'll just go with, just finish chart number 6. Because then it's going to get weird again. We're going to get into the multivalent ions, which unfortunately just get way trickier, Aiden. I can't fix that. If you finish number 6 early and you want to work on the take-home quiz, you can. I'm going to hit pause until magnesium. Okay?